In this video, we are going to simplify rational expressions. And rational expression is a fancy word for a fraction. So we're going to get into some complicated versions here, but let's just start with something really easy. I promise this isn't going to be what this video is about, but it's important to think about how you would simplify a fraction like this when you start to consider how you would simplify a fraction like, say we have 2r minus 5 over r squared minus 5r plus 4. So how would you simplify a fraction like this? This is what we call a rational expression, right? We've got an expression in the numerator, an expression in the denominator, and we want to simplify this. So in order to think about how you do that, you really need to follow the same exact rules you would follow if you were simplifying 10/15ths. And I think most of you know how to do that, right? So you really think about what are the factors of the numerator and what are the factors of the denominator. And this is key. I'm going to be using this word factor a lot, and I want you to remember what that means. So a factor is something that multiplies to give another number, or something that you could divide into that number without a remainder. So the factors of 10 are 1, 2, 5, and 10. The factors of 15 are 1, 3, 5, and 15. When it comes to reducing fractions, we really don't care about the 1. It's not going to do anything for us, but we do care about the other numbers. So I changed 10 into 2 times 5 and 15 into 3 times 5, and we see that we have a common factor in the numerator and the denominator. And that allows us to divide. So we can do 5 divided by 5, and that gives us 1. And 2 times 1 is 2, and 3 times 1 is 3, and so we end up with 2/3, which most of you knew was going to be the case. But the key here is I want you to see that what you're reducing or canceling, depending on which word you prefer, are common factors. So when you get to an expression like this, you have to think about factoring. I really can't tell you how many times I've seen people, I don't even want to do it. Maybe I'll do it. I'll do it. I hate to do it. Cancel these R's. Oh, that makes me cringe inside a little bit, because R is not a factor of the numerator and R is not a factor of the denominator, so you can't cancel those. It'd be similar to doing this. Oh, I hope nobody is watching this with the volume down. They're going to think I'm crazy. It'd be similar to doing, oh, I say 10 is 8 plus 2, and 15 is 13 plus 2. So I'll just cancel these 2's, and the answer is 8/13. You can't reduce those 2's because 2 is not a factor, right? When you're adding or subtracting something, it's not a factor. It has to be multiplied. That's why you can't cancel these R's like that. I'm going to hit undo as many times as I can. Let's see if I can get rid of those. There we go. Oh, that makes me feel better. Okay. So we have to factor the numerator and factor the denominator. Actually, let me change a number here. I'm going to change this to just R, and then I'm going to change this 5 so it actually does something interesting here. I'm going to change this 5 to a 1. Okay. So we look at the numerator, and the numerator doesn't factor. If you have r to the first power, it's not going to factor at all. And in the denominator, we have a trinomial. If you are iffy on your factoring, you need to go back and learn that. I have a playlist on factoring that covers all the different kinds of factoring, and you will need to know how to do this for simplifying rational expressions and for all of the things that are coming after this in your class, which is going to be adding fractions like this together, multiplying fractions like this, subtracting, and dividing. All right, so this is an easy trinomial because it has a leading coefficient of 1. So I just have to think of, I can put r here and an r here, and then I need to think of two numbers that multiply to be 4 and add to be -5. So that would be a -4 times a -1. Now, my factors in my denominator, I have two factors. I have a factor of r minus 4, and I have a factor of r minus 1. Because these two things multiply together to be r squared minus 5r plus 4. In the numerator, I just have r minus 1 as a factor. I guess technically you could think of it as you have 1 times r minus 1 if you want. It's sort of like it's prime. It's not going to factor. Well, we have a common factor of r minus 1. This r minus 1 is like this 5 over here. You can cancel this r minus 1 out because it is a factor that is shared by both the numerator and the denominator. And that leaves us with 1 over r minus 4, and that is our answer. That is the answer, okay? Now, a little stipulation here. When you have a fraction, remember you can't divide by 0, all right? We don't want our denominator to be 0. So a lot of times you'll be asked, for what values of r is this fraction undefined? And so you would look at the denominator and you would ask yourself, before you do the canceling, what value of r would make this factor 0? And that would be, we can kind of do that in our head, but this is what you're asking yourself. What value of r would make r minus 4 0? Because if this was 0, my denominator would be 0, and that would be bad. All right, so if r was 4, that would make 4 minus 4 0. That would be bad, so I say r can't be 4. Similarly, I would ask myself, what value of r, take away 1, would leave me 0, and of course that would be 1, and that would be bad. So if you were asked to restrict your domain, or for what values of the variable is the fraction undefined, this would be the answer to that question. Okay, so this fraction does reduce to 1 over r minus 4, as long as r is not equal to 1 and r is not equal to 4. Because if r was 1 or 4, we would end up with a fraction that's undefined. All right, let's try another one. I'm going to try a little different one. Oops, wrong thing. Let's try that again. A little different one here. Let's try one that has just like one term. Say 6x squared y over 18x y to the fifth. Okay, so when we think about the factors of the numerator and the denominator here, we don't have a binomial or a trinomial that we need to factor. We just have one term in the numerator and one term in the denominator. So we could think of the numerator as 6 times x times x times y. And I'll just leave the 18, even though I'm going to think of that as 6 times 3, x, and then y to the fifth. So when you only have one term in the numerator and the denominator, you can just think of the exponent as listing out all the factors, y times y times y, that gives you y to the fifth. And then you can see what you can cancel here, right? So x divided by x would be 1. And then y divided by y would be 1. And 6 goes into 6 once, and 6 goes into 18 3 times. So what am I left with in the numerator? Looks like just in 1 times x. And in the denominator, I have a 3 and y to the fourth. So that would be the answer there. So that's a different kind of factoring. It's not tough like the trinomials when it's just one term. As far as restricting this, we would see, because of this x, I wouldn't want x to be 0. And because of this y, I wouldn't want y to be 0 for restricting that domain. All right, let's try one more. There's a little, maybe two. Sometimes I just can't stop. Let me show you one thing when you're factoring that can be a little bit tricky. I'm going to write this already factored just to save a little time. Let's say you come up with something like this and you had x plus 1 and then x minus 2, and then down here you had 1 plus x, and here you had 2 minus x. So you see what I did? I switched the order. So if the order switch doesn't matter. All right, so let's think about this x plus 1 and this 1 plus x. Maybe I'll just write that over here as a separate problem. Does that reduce to 1? Can you cancel these factors? And the answer is yes, because, oops, I switched it around. Because 1 plus x can be written as x plus 1 because of the commutative property, right? You can switch those around. They're the same thing. It doesn't matter. So yeah, I could cancel these out. It doesn't matter if there's a plus. But what about a minus, right? Subtraction is not commutative. If you have something like 8 minus 2, that's not the same as 2 minus 8. It's close, right? This is going to be 6 and this is going to be negative 6. They're going to end up being the same number, absolute value wise, but one's going to be positive and one's going to be negative. So what would this reduce to? Well, that would reduce to negative 1, right? Let's try another one. What if you had 2 minus 18 over 18 minus 2? The top's going to be negative 16. The bottom's going to be positive 16. That's going to reduce to negative 1. And that will always happen if you switch the order of the subtraction. One's going to be positive, one's going to be negative, the same absolute value. So, can you reduce x minus 2 over 2 minus x? The answer is yes, you can. It doesn't reduce to 1 though, right? 1 plus x divided by x plus 1 is going to be 1. This guy is going to reduce to negative 1. Not negative 1 over negative 1, because that'd be positive 1. Just negative 1. Okay, you could put negative 1 over 1 if you wanted to, but basically you can cancel these factors, but you have to put a negative 1 in there. So the answer to this problem, to reduce this problem, would be negative 1. Would reduce down to negative 1. All right, let's see what this would look like in a bigger problem. Let's do one that has difference of squares. Let's say we've got x squared plus 7x, no, I'll do minus 7x. X squared minus 7x plus 10 over 4 minus x squared. All right, we want to reduce this fraction. So again, remember, this is the key. You have to factor. You have to think about what the factors are because you can only cancel factors. Well, in the numerator, we have a trinomial. So we can factor that trinomial, and that's a easy trinomial, as I like to call them, because the leading coefficient is 1. So this would give me an x, and I just need to figure out what multiplies to be positive 10 and adds to be negative 7. And that would be negative 2 times negative 5. That gives me positive 10, and it adds to be negative 7. And you could check it by foiling this out. In the denominator, we have what's called the difference of two perfect squares. 4 is a perfect square because it's 2 times 2, and x squared is a perfect square because it's x times x. All right, since the 4 is first, you have to put the 2 and 2 first in the parentheses. And since the x is last, or after the minus sign, you have to put the x at the end of the parentheses. And then you have to make one a plus and one a minus. It really doesn't matter which one. And if you FOIL this out, the middle term will drop out, so you're only left with 2 terms, and you end up with a negative x squared, which is what you want. So I look at this and I say, all right, I have 2 factors in the numerator, 2 factors in the denominator. I don't see any common factors, but I do notice that I have an x minus 2 and a 2 minus x, and I can reduce that down to negative 1, like that. So for my final answer, I would say in the numerator, I've got negative 1 times x minus 5. And in the denominator, I've got 2 plus x. And that's a perfectly fine answer. I don't know, your book may want you to distribute that negative 1, or your instructor. And I guess that's a little nicer if I distribute that negative 1 and write my answer like that. Now, if I wanted to think about restricting, okay, this would be my final answer, only if this fraction is defined. So remember, if you want to figure out what values of x make the fraction undefined, you look at the denominator and you say what value of x would make this factor 0, and that would be negative 2, because 2 plus negative 2 is 0, so I don't want that. And I look at my other factor, even though it got canceled, you need to consider it because of the original problem. I don't want x to be a positive 2, because a positive 2 would make this factor 0. And if you go back to the original problem, you see if you plugged in 2 or negative 2 for x, it would make the denominator 0, which is bad. Okay, so this might be part of your answer, depending on what the directions say. Sometimes when you're doing a problem, the direction will say, assume that it's, defined for all your variables, or basically there'll be something in there that says don't worry about listing the restrictions. But some problems will ask you to list the restrictions. All right, I hope that helps. So the basic idea is to factor and then reduce. It's really going to be dependent on your factoring ability. And again, if you need more help with factoring, you could go check out some of my factoring videos in the factoring playlist.